Hi ladies, in this video we're going to go through the theory and a few of the questions at the start of 6A, index notation. What we're going to do is, remember last time I focused on the difficult questions, but I'm going to do lots of videos for each section. So for each section I'm going to do the theory and some of the questions from the fluency part of it, and then I'm going to do a second video going through the difficult questions. So if you feel like you're confident with the first part of a section, then you can move. You can just watch the challenging questions video. Okay, so let's get started. So key ideas. So basically, indices, or the plural is an index, can be used to represent a product of the same factor. So you would have done something like this in year 7. So you've got the expanded form, so 2 times 2 times 2 times 2 times 2. Another way of representing that, because that is quite long, is just 2 to the power of 5. And if we did 2 to the power of 5, or 2 times 2, which is 4, times 2, which is 8, times 2, 16, times 2 is 32, you get, 32, your basic numeral. Just a few definitions. So your base is the number that we're taking the power to. Index is your power, okay, how many times that number or your base is being multiplied by. And your basic numeral is basically your answer. So here you've got some definitions, probably a bit better than how I just defined them. So the base is a factor in the product. Okay, so the factor here is 2. Product meaning multiply. The index, also known as the exponent or power. So you probably heard the word lately, exponentially, because, you know, we're in this pandemic where we've got the coronavirus, and basically things can increase exponentially. So that just means, you know, things can double every day. So that's how, you know, this pandemic has just got out of control, because it's not just multiplying by 2, it's increasing exponentially. And when you think about that, what that means is a graph, and let's see if I can get my pen working. Sometimes it doesn't want to cooperate. Oh, and today's a day you're not going to work for me. Let's just see if it's going to work. Oh, I don't have draw up there. All right, so I just paused it and fixed things. So draw wasn't coming up. So your exponential graph kind of goes like that. So you can see, you know, things start off quite slow, but then they just increase dramatically. And that's how, you know, the virus has been able to spread so very, very quickly, and how it's so dangerous. Okay, so that is basically how many times the factor is written. Okay, so if your index is 4, we're multiplying that base 4 times. Other things to note, that a to the power of 1 is just a. So if we had that as a number, 5 to the power of 1 is just 5, because that's 5 multiplied by itself just once. So it's just 5, or it's not really multiplied at all. And prime factorization. So using these what we call factor trees, you may have seen in year 7. Let's just get rid of this beautiful exponential graph that I just drew. So we don't really use them in year 9 indices, but I'll just explain how they work and what it means by prime factorization. So if I had a number, let's call that, I don't know, gosh, let me just think. Let's just do 24. And you've got to break that off into factor pairs. So what multiplies, what factors go into 24? So I can do 2 times 12. Okay, so 2 and 12. Now you keep going along your branches until you get to a prime number. So 2, we can stop there because that's a prime number. Then 12, it does have a factor pair of 2 and 6. And then we get 2 and 3. So we can represent 24 is the same as 2 times 2 times 2 times 3. So how many 2's have we got? 2 to the power of 3 times 3. So 2 to the power of 3 being 8, 8 times 3, and then we get back to 24. So that's what it means by prime factorization. So you can represent whole numbers, unless it's already a prime number. So any composite number, so a composite number is not a prime number, as in index form. Okay, so let's scroll down and do some questions. All right, so I have skipped questions 1 to 4 and gone straight to 5, but if you had any trouble with 1 to 4, just ask and I can help you, or your teacher can help you if I'm not your teacher. Okay, so question 5, write each of the following in index form. So let me just write over here, 5A. So we can write our base first. So the base is just the factor that's being multiplied. So that's 2/3. And then how many times is it being multiplied by? I've got 1, 2, 3, 4. Now, because it's a fraction, we've got to put that in brackets. Okay, because if I wrote it like this, it looks like only the 2 is to the power of 4. So put the whole thing in brackets. Because effectively, and you'll be learning this later because this isn't a part of this section, but you basically take your numerator and your denominator to the power of 4. All right, and we can do the same thing with another question. Let's maybe do question D because we've got a few different bases in there. Okay, so just do each one separately. So 7x over 9, put that in brackets. And how many of them do we have? We've got 1, 2, so it's 7x to the power of 9 times to the power of 2 times 1, 2, 3. So y to the power of 4. Sorry, not to the power of 4. Y over 4 to the power of 3. All right, let's look at question 6. Write each of the following in index form. So when you've got such a long expanded expression like this, and I'm going to rewrite it just to show you what I'm going to do. We've got y times x. And notice my x's and my multiply signs are different, so don't go writing your x's like this. Just making sure I've got them all. Gosh, it's so long. Times 3 times y. Hopefully I didn't forget anything. Now, you don't want to forget anything, so how many 3's have we got? We've got 1, 2, 3, 3, so it's going to be 3 to the power of 3 times x. We've got 1, 2, 3 x's, so maybe if I underline them so then I won't forget them. And we've got 1, 2 y, so y to the power of 2, and let's just underline that. Now, I didn't forget any y's, did I? Just make sure there is only 2 y's. Okay, and we don't have to put those multiply signs in because it's in algebraic expressions we usually don't. So 3 to the power of y, x to the power of 3, y to the power of 2. Okay, you could put the 3 and the x together to the power of 3, but that's an index law that we're going to cover later. So we're just going to leave that as 3 to the power of 3, x to the power of 3, y to the power of 2. All right, let's have a look at another one in question 6. Let's have a look at D. Oh, actually, I'm liking, now I can see C, and I'm just wondering whether the answer is going to be a little bit different. Okay, so I'm going to do that one because I think it's going to answer it one way, but we should technically answer it a different way. Okay, so I'm going to show you the first way. So how many 4Ds have we got? We've got 1, 2. Now, we've got to square that whole thing. So I'd be curious to know what the answer is for this. Okay, so we've got to square all of them. Now, when we can leave it like that, and I wouldn't be surprised if that's what the answer is because we're just starting with index notation. But one of your index laws actually means that we square everything inside the bracket. So it's going to be 4 squared d squared times 2 squared e squared. And if we're writing, now it's going to get complicated. Now we can either write this as a 4. Okay, so 2 squared is 4. So we can have 4 squared d squared times 4e squared. All right, and then we've got 4 squared, and this is actually 4 to the power of 1. So that can be 4 cubed d squared e squared. And this 4 cubed, if you wanted to, you could make that to the base 2. I'm just going to leave it for now because I don't want to complicate it. But I'm pretty sure for now, if you got that, that's fine. But we're going to be looking at index laws, which kind of converts this into this. Okay, or even having a base of 2 instead of 4, because 4 is the same as 2 squared. Okay, let's move on to the next, another question in question 6. Whoops, need to just get my pink pen. Now, which one do I want to do? Let's do E. Okay, so I've got 3PQ, 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 whoops, and another bracket, 3PQ. Now, this just still means we're multiplying, okay? There's kind of an implied multiply in here, and you would have done it back in year 7 when you started algebra, that there's an implied multiply in here. So it's not too different to what we've done before. So we're going to have 3PQ, and then we say, all right, and how many of them do we have? We've got 1, 2, 3, 4, so 3PQ to the power of 4. Now, like we did in the previous question, you can get rid of that bracket if you like, and everything inside it is to the power of 4, but that's something we're going to do later. So as long as you got this left-hand side, that's fine, but one of the index laws just states everything inside the bracket is taken to the power of 4. All right, let's have a look now before we... Okay, so question 7, we need to write the numbers in index form. Okay, so let's have a look first at question 10. So 10 is the same as, if you want to do this as a factor tree, 2, 5. And now we've got our prime factors. So 10 is the same as 2 times 5. Okay, so you're just writing that with your prime factors in index form. Let's do a bigger number because we couldn't really get too much of let's not do B, sorry. What do you call it? Factor tree, prime factor tree. Let's do 144. Okay, so if we're going to split this up, because 2 is a prime number, if it's an even number, I usually choose 2 as one of them. So then I say 2 times what gives me 144, so 2 times 72. Now you could have done 12 times 12 if you wanted to. There's many ways you can get your prime factors. So maybe I'll show you that way as well. So then 72 we can split up to 8 and times 9, and then 8 can become 2 and 4, and this 4 can become 2 and 2, and then 9 is 3 and 3. So when you're doing your prime factors, the purpose of doing this is because we've got 2, 2, 2, 2, and 3 and 3. We're left with just prime factors. So we can write 144 as 2 to the power of 1, 2, 3, 4, because we got 4 2's, and we got 2 3's. So 3 to the power of 2. Now, if you wanted to do that using 12 times 12, okay, so it doesn't matter what pair of factors you work with. So we know 12 times 12 is 144. Then we can split that up into 3 and 4, both of them. 3 is already a prime number, but 4 isn't. It can be split into 2 and 2. And you can see there, we've now got our prime numbers, so I'm going to circle them, just like we did before. And you'll notice we get the same answer. So it doesn't matter what factor pair you use. So we usually write the smaller number first, so 2 to the power of 1, 2, 3, 4, times 3 to the power of 2. Okay, so that's how you do your prime factors. Okay. Let's have a look at question 8. Trying to keep these videos under 15 minutes. So remember, if you needed help with the harder questions, there's a second video for 6A. Okay, so this is a substitution. So if A equals 3, B equals 2, C equals -3, we're just going to substitute them in. Actually, which question can we do? Now, we always do the easy ones. Let's do D. So B over C cubed. Oops. Okay, so B is 2. Okay, so B equals 2. C is -3. So -2 over 3 cubed. Now it says evaluate these expressions. So I'm just going to check if we have to do that any further. I'm wondering if this was a calculator question. Just give me 1 sec. Okay, so it's just interesting that they are getting you to use one of the index laws and we haven't even done it yet. Okay, so if you're taking a fraction to a power, you take the numerator to that power and the denominator to that power. So we're going to have, go away, -2 to the power of 3, 3 to the power of 3. Now this negative sign, because it's an odd power, it's going to be negative. If it was an even power, it would be positive, because negative times a negative gives you a positive answer. So 2 to the power of 3, remember, is 2 times 2 times 2. And 3 to the power of 3, which is 3 times 3 times 3. So 2 times 2 is 4, times 2 is 8, and then 3 times 3 is 9, times 3 gives you 27. All right, let's do another one. It's probably good that we did do that one. Let me just get my pen. Okay, let's do F. So we've got C squared plus AB. Okay, so C, when you've got a negative number, substituting in a negative number, I always put it in brackets just so we don't mix up our negatives. Okay, and I'll explain in a sec a common error people make. Okay, so -3 squared is -3, and I might just write it under here, times -3. So we're effectively multiplying two negative numbers. So we're going to get a positive answer. So when you square a negative, you get a positive answer. Okay, and then 3 times 2 is 6, so your answer is 15. All right, we might just do H and then we'll end this video. Oops. Okay, so C again is -3. And we're squaring that. Now, I like to put times in if we're dealing with numbers, just so, it doesn't look weird. So A is 3 and B is 2. So you could put the 2 in brackets if you want to, but because it's a positive number, I'm just going to leave it like that. Okay, so -3 squared, like we did before, we know it's 9 times 3, and then 2 cubed is 2 times 2 times 2, which is 8. And then we just go ahead and do that. Now, it's a bit hard sometimes when you're dealing with such a big number. So I would usually do, let's say, 9 times 8 first, which I know is 72. And then I'd multiply that by 3. So 72, which is the same as 72 plus 72 times plus 72, if you wanted to do it that way. So 72 plus 72 is 144, plus another 72, brings us to 200, oh gosh, let me just think, 216 from memory. Doing that in my head, let me just do it up quickly on my calculator. I hate it when my phone doesn't cooperate as a calculator. Go away. Okay, let's just 72 times 3. Okay, 216. There we go. All right, girls. See you later.